Musk has made the final call for Starship Flight 8. The mission is set for today from SpaceX's Starbase facility in Texas. The spacecraft, composed of Ship 34 and Booster 15, represents an improved version of the previous Starship iterations, integrating lessons from past failures. Preparations for this launch have been extensive. Booster 15 completed cryogenic testing on December 29, 2024, followed by a static fire test on February 9, 2025. Ship 34 underwent similar cryogenic tests in mid-January and a long-duration static fire test on February 11, 2025. Both components were stacked at Orbital Launch Mount A on March 2nd. The previous test, Flight Test 7, which launched on January 16, 2025, ended in failure due to a mid-flight fire caused by excess pressure in the propulsion system. The resulting explosion prompted a thorough investigation led by the FAA, NASA, the National Transportation Safety Board, and the U.S. Space Force. SpaceX engineers determined that extreme vibrations placed stress on the vehicle's structure, leading to leaks and fire. In response, they redesigned critical components, improving the avionics system, modifying the forward flaps to reduce overheating, and strengthening the propulsion system for increased reliability. After an extensive review, the FAA granted SpaceX the necessary launch license on February 26, 2025. With safety and environmental considerations addressed, the countdown for Flight Test 8 is officially underway. This mission is packed with ambitious objectives. First, the test aims to evaluate how well the Super Heavy booster and Starship separate in flight. It also includes deploying 4 Starlink simulator satellites which will re-enter Earth's atmosphere over the Indian Ocean, further validating Starship's potential as a satellite deployment platform. Another key objective is the in-space relight test of the Raptor engine, which is essential for future missions that require mid-mission engine restarts, such as landing on the Moon or Mars. SpaceX also aims to achieve a significant milestone in booster recovery. The Super Heavy booster will attempt a boost-back burn to return to the launch site, where it will be caught mid-air using the mechanical arms of the launch tower. This is an extremely difficult maneuver, as no rocket in history has ever been recovered in this way. Meanwhile, Starship itself will perform a controlled descent and splashdown in the Indian Ocean. Musk has been actively sharing updates about the launch. On February 24th, he posted on X, formerly Twitter, stating, "Starship Flight 8 flies Friday." However, due to last-minute preparations, the launch was rescheduled to March 3rd. SpaceX has made it clear that even if the mission does not go exactly as planned, the data gathered will be invaluable for future improvements. For those eager to watch history unfold, SpaceX has scheduled a live webcast of the launch, expected to begin approximately 45 minutes before liftoff. As with all rocket launches, delays are possible depending on technical readiness and weather conditions. However, if all goes according to plan, it will bring SpaceX one step closer to achieving Musk's long-term goal of making life multiplanetary. According to Musk's estimates, the first uncrewed starships could head to Mars as early as 2026, with crewed missions following by 2028. He envisions a self-sustaining city on Mars within the next 2 decades, a vision that depends entirely on Starship proving itself as a reliable spacecraft. While SpaceX is preparing for the highly anticipated Starship Flight 8, the company hasn't been focusing only on Starship. Just recently, they achieved another major success with their Falcon 9 rocket, which launched a lunar lander carrying 3 robotic missions to the Moon. The most important of these is Firefly Aerospace's Blue Ghost lander, which is now in lunar orbit preparing for landing. This mission is part of NASA's Commercial Lunar Payload Services program, where private companies are contracted to deliver scientific equipment and experiments to the Moon. Instead of taking a direct path to the surface, the lander took a longer route, which allowed engineers to carefully adjust its course and collect data along the way. On February 18th, the spacecraft took a close-up picture of the Moon's far side, which is never visible from Earth. It also captured detailed images of craters, rugged terrain, and even the lunar South Pole, an area of great interest for future missions. Aside from taking pictures, the mission has already achieved a groundbreaking milestone that could change the way spacecraft navigate in deep space. For the first time ever, the spacecraft picked up signals from Earth's GPS satellites while in lunar orbit. This is a major achievement because GPS, the system that helps us navigate on Earth, was never designed to function beyond our planet's immediate surroundings. It relies on a network of satellites orbiting Earth at about 12,550 miles above the surface, continuously broadcasting signals that allow devices like smartphones and cars to determine their location. These signals weaken the farther they travel, which is why they were not expected to be useful at the extreme distances of deep space. Engineers had long assumed that beyond a certain range, GPS signals would be too weak and unreliable to provide any useful information. Space missions that go beyond Earth's orbit, such as those to the Moon or Mars, traditionally rely on other navigation methods. For example, NASA uses ground-based tracking stations on Earth to communicate with spacecraft and estimate their location. However, this method is not always precise, and it requires constant communication between mission control and the spacecraft. If deep space missions could use GPS signals directly instead, they would be able to navigate more independently, reducing the need for ground intervention. Blue Ghost's ability to lock onto GPS signals from 246,000 miles away proves that even in deep space, there is still enough signal strength to be detected and used for navigation. This breakthrough could change how future moon missions are planned. Instead of relying entirely on Earth-based tracking, spacecraft heading to the moon might be able to use GPS-like positioning, just as airplanes and ships use GPS to navigate across the globe. This would make future missions more efficient and allow spacecraft to make real-time adjustments to their trajectories without waiting for commands from Earth. This success could change how spacecraft navigate in the future. Right now, missions to the moon rely on pre-planned calculations and ground-based tracking stations to determine their location. If future moon missions can use Earth's GPS signals, it could make space travel much simpler and more autonomous, reducing the need for constant communication with ground control. While new companies like Firefly Aerospace are making impressive progress, Boeing is struggling with its Starliner spacecraft, facing major failures and financial losses. The latest crewed flight of Starliner turned into a disaster, leaving 2 NASA astronauts stuck on the International Space Station for months longer than planned. NASA astronauts Sunita Williams and Butch Wilmore were supposed to fly to the International Space Station for a short test mission in June 2024 and return after about a week. But after docking at the station, serious technical problems were discovered, including failures in the thrusters that help control the spacecraft and multiple helium leaks. NASA decided it was too risky to bring them back using Starliner, leaving them stranded on the International Space Station. Now, more than 8 months later, the astronauts are still waiting for a safe way to return to Earth. NASA has confirmed that instead of using Starliner, Williams and Wilmore will likely return aboard SpaceX's Crew Dragon in the coming months. Williams' mother has spoken publicly about the situation, saying her daughter is honored to be part of the mission, but the delay is clearly far from ideal. The situation has been a huge embarrassment for Boeing. Last year, NASA and Boeing agreed to bring the Starliner capsule back to Earth without any crew, as it was simply not safe for human re-entry. Financially, Starliner has been a massive failure for Boeing. In 2024 alone, the company lost $523 million on the program, bringing total losses to over $2 billion since it began. These costs come from repeated delays, technical problems, and extra spending on testing and certification. With so much money lost and no successful crewed missions, Boeing is now considering shutting down the program altogether. Some reports suggest they may even try to sell it to another company. That's all for today's video. Thanks for watching.